Solving trig equations with factoring. As our trig equations get a little bit more complicated, it's really just step A that's going to require a bit more work. Once we get the equation in that good format, the rest of the steps will be the same. So take a look at this example equation here. We want to solve for x. We want all the solutions. We're doing this by hand, and we are working in terms of radians. Now, this equation, there's a lot going on here. I certainly don't have any short, simple way to write the equation in this good format. I have multiple trig functions here. These aren't like terms. Well, one method to consider is the factoring method. The factoring method only works if there's a 0 on one side, as we will see. I do have that here. Let's try to factor the left side. Well, the first and most basic type of factoring is pull out the GCF, and I see I have a GCF. I have a sine x in this term, and I have a sine x in that term, so I can pull that out to the front, leaving me with cosine x here and minus 2 from the other one. Well, hopefully you remember from algebra that if you multiply two items together, and the answer comes out to be 0. This is why that 0 was so important. If you multiply two things together and the answer is 0, the only way that can happen is if one or the other of those two initial pieces is 0. The only way to end up with a product of 0 is if at least one of the pieces is equal to 0. And so that's what you write down. Either sine x is 0 or cosine x minus 2 is 0. Well, here's what's happened. I've taken that complicated trig equation and I've split it into now two more simple trig equations. Look, the first one is already in the good format, trig function x equals 0. And the second one, all I have to do is add 2 to both sides, and then it too will be in that good format, cosine x equals 2. Solve each one of these equations and you will have the solutions that you need. Okay, we finished step A. Let's move on now to step B. We're going to have to apply step B twice for each of our simple equations, except, do you see we get off easy here? This second equation, cosine x equals 2, should raise some red flags. I can't have a cosine ratio that's equal to 2. The highest cosine ratio is 1. So this equation is impossible. I don't need to worry about it. I only need to worry about sine x equals 0. It's time for me to draw some pictures so that I can carry out step B. And of course, when I see 0 as a sine ratio, I know I'm going to have to go to the unit circle. I'm looking for all the spots within one rotation, 0 to 2 pi, where you get a sine value of 0. Sine is the b coordinate. So one place that happens is right here at 1, 0. The only other place with a b coordinate of 0 would be across the way at -1, 0. So these two angles are the angles we're talking about here, 0 radians and pi radians. We are working in terms of radians. And those are the only two angles within one period that satisfy the equation where there's a sine ratio of 0. Well, I do want all the solutions, so I'm ready then to move into step C. And of course, normally I would be adding multiples of 2 pi on to each of those two solutions that we found. But what I notice from my picture is that my two solutions are evenly spaced. So I know I can write all the solutions in just one line. If I take the very first one, 0 radians, instead of adding multiples of 2 pi, if I just add multiples of the distance between the answers, which is pi, right? Pi to get to this answer, another pi to the next one, another pi, and so on. That covers every single answer possible. In fact, this even simplifies. I don't need the 0. The final answer here would be x equals k pi. That covers 0 pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi. We're saying that one line summarizes all the solutions to that equation. Thanks for watching.